Hello, this video is for IXL Activity 8.W.8. It is titled Solve Two-Step Equations. The three-character code for this activity is Juliet X-ray Delta. So whenever we solve two-step equations, well, we're going to have to do two steps. We've done one-step equations before where we only had to add or subtract or multiply or divide. Now we're going to have to do some addition or subtraction, and then we're going to have to do some multiplication or division and using inverse operations, or as I like to say, opposite operations, in order to undo these. And the object in the end is to isolate the variable, right, so that we can get an answer. So that's what it's all about. Solving an equation is all about isolating that variable and coming up with a numerical value that variable is equal to, right? So on the first one, always good to rewrite the problem. So we'll go with 3t plus 3 equals 9. So we need to get the t by itself, but before we can do that, we have to deal with this positive 3. So the 3 is related to the 3t through addition, so we need to use subtraction, the opposite operation. We're going to subtract the very number we wish to get rid of, and what we do to one side, well, we're going to do to the other. Whenever we do that, what's going to happen is the 3's are going to cancel each other out, at least the positive 3 and the negative 3, leaving us with just 3t, and 9 minus 3 is going to be 6. Now the 3 is tied to the t through multiplication. This is going to be our second step. Our first step was here. This was the first step, and this is why we call it a two-step equation, because we have two steps. Now we're going to do the second step here. This is going to be our second step, and that is going to be to divide. Because the 3 is tied to the t through multiplication, the opposite operation of multiplication is division, so we're going to use a fraction because all fractions are division problems. And we're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we're going to do to the other. So the 3 is going to cancel each other, leaving us with just t, and 6 divided by 3 is 2. So we'll plug in a 2 there. Remember, you can always check your answer by substituting the value back in 3 times whatever we found out for t, which is 2, and then plus 3. And 3 times 2 is 6, plus 3 equals, and indeed it does equal 9, so we see that that worked out just fine. On our next one, we have 8 equals 6 plus 2v. So our variable is on the right. I kind of like it over here on the left, so we can just go, this is an equal sign, so we can just move what's on the left to the right and vice versa, what's on the right to the left, etc. So I'm going to write this as 6 plus 2v equals 8. So before I deal with the 2v here, I have to deal with the 6. So I'm going to subtract 6 to get rid of the positive 6. So what I do to one side, I'm going to do to the other. And those 6's are going to cancel each other out, leaving me with 2v equals, and 6 minus 8 is 2. So that's the first step. Second step is to divide, and we're going to divide because the 2 is tied to the v through multiplication. The opposite operation is division. We're going to divide by the number we wish to get rid of, and what we do to one side, we are going to do to the other. The 2's are going to cancel each other, leaving us with v, and 2 over 2 is equal to 1. So in this case, v equals 1. And if we plugged in a 1 there, we would get 2 times 2, 1 is 2, and 6 plus 2 is indeed 8. So we're good to go. v equals 1. On the next one, 2w minus 5 equals 3. So we need to deal with this negative 5 first, because remember that is actually 2w plus negative 5. We change this to addition. Take the opposite of the next number. So we need to add 5. So our first step is to add 5. And that means that these 5's going to cancel each other because they're opposites, leaving us with just 2w on the left. And 3 plus 5 is 8. Now the 2 is tied to the w through multiplication, so let's undo that with division. We're going to divide by the number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. The 2's will cancel each other, leaving us with w. And 8 divided by 2 is 4. So w equals 4. On the next one, you know me, I like to get them variables over on the left. So I'm going to do 4 plus 3b equals 10. I just flipped them around. We can do that. And let's go ahead and deal with this positive 4 so we can get to the multiplication with the 3b. So our first step is to subtract 4. What we do to one side, we're going to do to the other. And these 4's are going to cancel each other out because they're opposites. That equals 0, and 0 plus 3b is simply 3b, and 10 minus 4 is 6. Second step is to divide because we have multiplication going on here between the 3 and the b, and we're going to divide by the number we wish to get rid of, which is 3, and what we do to one side, we're going to do to the other. So these 3's will cancel each other out, leaving us with b, and 6 divided by 3 is 2, so b equals 2. Our next one here, we see that we got some division going on between the variable and the value of 3. But first we're going to have to deal with this 11 here. So let's go ahead and do the g over 3 plus 11 equals 14. And let's go ahead and subtract 11, right? So subtract 11 from both sides. And these are going to cancel each other out, leaving us with g over 3. And 14 minus 11 is 3. Now, the g is tied to the 3 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 3. And what we do to one side, we are going to do to the other. We know that these 3's are going to cancel each other out, leaving us with just g on the left. And 3 times 3 is 9. So g equals 9. Again, I like my variables to be on the left, so I'm going to go ahead and move them over there. So q over 9. And this is a q there, put a tail on it, there we go, plus negative 31 equals negative 30. So I rewrote it, got it set up. Let's go ahead and, so we have a negative 31 here, plus a negative 31, that's the same as minus 31. This is great because we can see that this is negative 31, and the opposite of negative 31 is a positive 31. So we're actually adding 31 to each side. So these are going to cancel each other out, leaving us with q over 9 equals, and negative 31, or negative 30 plus 31 is going to give us a positive 1. Now we need to multiply because the q is tied to the 9 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 9. And what we do to one side, we do to the other. So the 9's will cancel each other, leaving us with q equals, and 1 times 9 is 9. So equals 9. And if we plug that in, we'd see that 9 over 9, right? 9 over 9 equals 1. And 1 plus negative 31, it's going to give us negative 30. So we know our answer is correct. Here we have a parentheses, quantity of n plus 40. But there's this negative sign out in front of it. I've talked about this in other activities where we could look at this in one of two ways. The opposite of n plus 40, so the opposite of everything that's on the inside of here. So we could say that's negative n, it's positive, so it becomes negative. And this is a positive 40, so it becomes a negative 40, and equals 32. So we could do it that way, or we could look at it as, we could put a 1 in front of this, right? N plus 40. We could put a 1 in front of that and not change the value of it, right? Because anything times 1 is equal to itself. So these two are equivalent expressions. And then we could distribute the negative 1 in. So negative 1 times positive n is a negative n. And negative 1 times 40 is going to be, we write that as minus 40, negative 40. But we remember that we could change the sign from subtraction to addition and take the opposite. So either way, we still end up with n plus negative n plus negative 40, and then equals 32. So either way, we get the same result. So I'm going to go ahead and I'm going to erase this here, and we realize that from here to here, I've just gone ahead and either took the opposite of everything on the inside or distributed a negative 1 into it. Now, the next thing I need to do is get rid of this negative 40 here, right? So let's add 40. So what I do to one side, I have to do to the other. And whenever I do that, these are going to cancel each other, leave me with just negative n. And 32 plus 40 is going to be, 72, right? Now, I have a negative n. I cannot have this as a negative. We talked about this in the lesson with the algebra tiles, that we can go ahead and divide both sides by negative 1, right? And negative divided by negative is positive, because what I did to one side, I did to the other. So this is a legal move I can do here. So negative divided by negative is positive. N divided by 1 is still n. And 72 divided by negative 1, positive divided by negative is negative. and 72 divided by 1 is 72. So I want you to look at what happens whenever you divide by this negative 1 here. What happens? We simply just change the sign of each of them. So I have a negative n, I want a positive n. So I'm just going to make the positive or the negative a positive, but over here I have to change this over here. So this was a positive, it becomes a negative. And whenever you do that, that's what's happening is you're dividing by a negative 1. All right, on the next one here, we have 72. And we need to distribute this 9 into the quantity of b plus 7, right? So 9 times b equals 9b. And 9 times 7 is going to be a positive 63. So now I can go ahead and, you know me, I like my variables over here on the right or on the left. So I'm going to go ahead and do that. 9b plus 63 equals 72. Now I need to subtract 63 to get rid of the addition here, right? So minus 63. What we do to one side, we do to the other. And that's going to cancel those 63s. So I'm going to get 9b. And 72 minus 63. Well, 63, the difference between these two is, what is that? 9, right? So, yep. So we're going to get 72 minus 63 is 9. And now 9 is tied to the b through multiplication. We're going to use division to undo it. We're going to divide by the number we wish to get rid of, which is 9. And what we do to one side, we're going to do to the other. And so we get canceled out there, and we end up with b. And 9 over 9 equals 1. So it says that we plug in 1 right here. So 1 plus 7 is 8. 9 times 8 equals 72. And indeed, we see we get the same thing. 72 is equal to 72. So indeed, b equals 1. For the next one here, we have negative 5r plus negative 23 equals negative 63. So let's go ahead and first get rid of this negative 23 by adding 23, right? So we're going to add a positive 23 to each side. And whenever we do that, the negative 23 and positive 23 cancel each other out, leaving us with negative 5r. And then negative 63 plus 23. So we're adding, look over here with negative 63 plus 23. We're adding two integers. One's positive, one's negative. So we know that we're actually going to subtract. So we're going to take the 63 and subtract the 23 and end up getting 40. Now, is this 40 positive or negative? Well, we know it's negative because the absolute value of 63 is greater than the absolute value of 23. So the one with the greater absolute value has the sign. It's like the sign wins out. It's the answer should be the same as the sign that belongs to whichever one had the greater absolute value. So 63 has the greater absolute value and it's negative, so our answer is negative also. So that's negative 40. Now the negative 5 is tied to the r through multiplication, the opposite operations division. We're going to divide by the very number we wish to get rid of, which is negative 5. And what we do to one side, we're going to do to the other. Cancel those out, and we end up with just r. Negative divided by negative is positive. 40 divided by 5 is 8. R equals 8. On the next one here, we need to do something to get rid of this fraction. The best way to get rid of a fraction is multiply both sides by its denominator. So let's put this in parentheses here, and we're going to multiply by 2. And so we're going to multiply this by 2 as well. So these 2's will cancel each other out. The reason why this is like 2 over 1, right? And so we multiply straight across. We'd end up with 2 over 2 through a bunch of steps. We get 2 over 2. That would be equal to 1. And then we would end up with what's in the denominator here. So z minus, and I'm going to cross that z so we know it's a z. Z minus 11.7. So this is what happens to the left side when we multiply by 2. Now over here we have 22.9 times 2. Well, in my head I would do that 30 times 2 is 60. 60 minus 2 is 58. And one place behind the decimal is 5.8. So there's my mental math for it. But if I went the other way, 2 times 9 is 18. I'm going to carry the 1. 2 times 2 is 4 plus the 1 is 58. I've got 1 behind the decimal here and nothing behind the decimal there. So 1 plus 0 is 1. So I need to move the decimal over one place. So I get 5.8 equals 5.8. Now, the next thing I need to do is deal with this. This is actually what, plus a negative 11, right? Change it, subtraction to addition, take the opposite of the next one. So this is a negative 11.7. So I need to add 11.7. And what I do to one side, you guessed it, I'm going to do to the other. And I'm going to line these decimals up for the addition of decimals. We've done that class before. And what happens is the negative cancels out the positive, and we end up with just z. And then we're adding these here. So 8 plus, put a decimal for placeholder. 8 plus 7 is 15. Carry the 1. 5, 6, 7. And bring this one down. We end up with 17.5. So 17.5 is our final answer. Last two questions here. We got a distributive property here we got to deal with. So let's go ahead and do that. I have 18.9 equals, distribute this 2.7 times r is 2.7r. And then this is a positive times a negative, so this is going to be a negative. And 2.7 times 11, 2.7 times 11, 7, 2, 7, 2. I'm kind of speeding through this. Hopefully we've gotten multiplying 2 digits by 2 digits down. That's 9. That's 2. I got 1 behind the decimal here and none behind the decimal here, so I need to move the decimal over one place. Move it over there, and I get 29.7. 29.7. All right, so now I have this 29.7 that's tied through subtraction, so we're going to use addition. Or if you want to look at it this way, this is plus a negative, so we have a negative 29.7. So we're adding 29.7 to get rid of it on that side. But what we do to one side, 29.7, we have to do to the other side. So these will cancel each other out, leaving us with 2.7r. You might be saying, I thought you liked your variables on the left. I do, but I'm here already, so I'll continue on. Show that it works either way. So I'm adding this. So the 9 plus, oh, I'll put my decimal down there for place. There you go. 9 plus 7 is 16. I'm going to carry the 1. 1 and 8 is 9. 9 and 9 is 18. Carry the 1 and 2. 1 plus 1 is 2. Plus 2 is 4. So now I have 48.6 equals 2.7r. So the 2.7 is tied to the r through multiplication. We're going to use the opposite operation, which is division. And we're going to divide by the very number we wish to get rid of, which is 2.7. And what we do to one side, we're going to do to the other. So the 2.7s will cancel each other, leaving us with just r. Now we got to do 48.6 divided by 2.7. 48.6 divided by 2.7. Calculator make this a lot easier, won't it? And many students probably will. So we need to move the decimal over 1 on each of these. We saw that in our multiplying and dividing decimals lesson. 27 will not go into 4, but it will go into 48. Let me see how many times. 27, 50, we only go once. And so that's going to be 27. And 8 minus 7 is 1. 4 minus 2 is 2. So bring down that 6. And 27 into 216. 25, 8 times. I'm going to try, let's try an 8. 8 times 7 is 56. I bet you this will work. 5, 8, 16 plus 5 is 21. Outstanding. Bet. End up at 0, so 18 is our answer. R equals 18. And yes, that would probably work a lot better with a calculator. I presume many of my students are probably going to use a calculator on something like that. So let's get that out of there. And for the last one, this minus a negative would probably work a lot better, 3c, if it were plus a positive. So change the subtraction to addition. Take the opposite of the following value. So negative 4.6 becomes positive 4.6 equals 10.6. So let's go ahead and get rid of this positive 4.6 by subtracting 4.6. Got to get that out of there before we can deal with the multiplication over here with the 3c. What we do to one side, we're going to do to the other. So we're going to subtract 4.6 here as well. These will cancel each other out, right, leaving us with 3c. And then 10.6 minus 4.6, well, 6 minus 6 is 0, and 10 minus 4 is 6. So we have 6.0, which is the same as just 6, right? And now the 3 is tied to the c through multiplication. The opposite operation is division. We're going to divide the very number we wish to get rid of, which is 3. And what we do to one side, we do to the other. The 3's cancel each other, leaving us with just c. And 6 divided by 3 is 2. So remember, in two-step equations, you have to first go ahead and deal with, I'll go back to the easy ones first. We have to deal with this -5 before we can get to the 2w, or we have to deal with the 4 before we can get to the 3b. So we had to subtract 4 before we divided by 3. Then we had other problems to where we had to deal with distributing and the negative. So we had some going on there. Here we had some distributive property going on there. And then also we had the idea of dividing by a negative coefficient and dealing with multiplying and dividing positive and negative numbers. That was in there. Something like this one here, where we had to multiply by the denominator to first eliminate the fraction out of it to get it down to where we had no fraction in it. And then also we had up here where we started having to deal with some decimal problems. So that's about the highest level of difficulty you're going to see in it. All right, so those are all of my examples for IXL 8.W.8, where we solve two-step equations. Good luck with your activity.